What comes to your mind when you see something like this?
So monumental buildings.
Monumental. Given that it's a mathematics focused class, does anything else come to your mind?
So parabola.
Parabola. Interesting. Anything else?
Sir, arc.
Arc. Interesting. Okay. Do you find any similarity between this structure and that structure? The second one and the first one?
It is like built in a semicircular, like that type of shape.
Any challenge in building such shape? Any challenge?
How can we support the top place?
How can you support? That's the brilliant part of it. How can you support? As Satish is right, is symmetrical, yes, from an aesthetic point of view. But I would like to explore on the point which Ritesh cracked on. How will you support? So what is the support here? Now you see. First of all, you tell me why there is no support in this architecture. Why there is no support? Why there is no support here?
So that boats can pass through.
Boats can pass. You can't have a support. If you have a support here, boat of this size cannot pass. And here?
People.
People can move.
People cannot go.
Yeah. Do you see such buildings with not support, with not much support longer distance? Have you seen in your places where you stay nearby? Do you see such places where buildings, do you see any requirement for such buildings in your building or nearby without support, without much support?
So like over here in Oman, we have these mosques which don't have much support.
Yeah, okay. Sometimes car parking places with less support, right? With less number of pillars, right?
Yes, sir.
You can accommodate more cars. Domes, yes, domes, yeah. Okay. So where from the support is coming? This one. Now, how is it standing?
The pillars in either side.
Pillars on either side. This side and this side, right? So without pillars, if you can stand, why do you need pillars at all? You can, like in all the buildings, you can, on the either side, you can keep pillars and make buildings like this, right? Why do you keep all this pillar in all the buildings? And so the car you have to take like this. So difficult. Why do you need pillars for bridges, big buildings? You can keep like this on either side, pillar and support, right? Any idea?
Because they need more support when they're heavier.
Yeah, when you are heavier, you need more support, right? There is a limit up to which you can support from here, right? Have you seen such kind of bridges? Where does the support comes from? This one?
So I guess about the top, like the hanging things, the rope.
The ropes.
Is the support coming from the rope?
Yeah.
Okay. Where is the rope getting support from?
From the two pillars, like
Yeah.
Place.
So these two pillars do the support, right? So that big ships can pass. So recently we had this issue in Suez Canal, right?
Yes, sir.
Yeah, the ship getting blocked. Ever given?
Ever given, yeah.
Yeah. So even with such a passage, you have issues, right? Yeah, suspension bridges, kind of stuff like this. Okay. So now the other way is straightforward stuff is pillars like this. So now this here also you see this pillar is giving a support from here, from bottom, like what Abel told. Heavier structure, you give a support like this, but this one is giving a support from here. Mathematically, strength wise, what is the difference between this and this?
So the pillar, the one with the pillar will be more stable.
This will be more stable, says Fish. Okay. What is the difference between a structure like this, which gives support from bottom, and a structure like this, which gives a support like this? Which should be stronger? This pillar should be stronger, or this pillar should be stronger? Assuming both these bridges are, let us assume, same mass, same weight. Assume that only two pillars are there. One pillar, only two pillars. Here also one pillar and two pillars. Which pillar need to be strong? A or B? Everyone.
Sorry.
A, sir.
Why?
So because a lot of vehicles go through it, and there's
let me repeat my question. Assume all other conditions are same. Assume these two bridges are same bridges. Exactly same bridges. Number of vehicles, mass, everything is same. One is supported like this from top, like this. Another is supported with two from here. Weight, everything is same. So support from bottom, it need to be stronger, or this need to be stronger?
So A will be more stronger. Also, because of the design during natural calamities like earthquakes and all, it can withstand, the
Earthquake doesn't affect this support.
So mostly no, right? Because it doesn't have contact with the ground that much as the bridge B.
Okay, so this also actually this pillar is in ground only. Okay. So
It's because of the ropes that are hanging.
because of the ropes, what happens, Abel? Because of the ropes, what happens?
The ropes hold the bridge up a bit,
Okay, so
it won't fall down that easily.
So just to give, do you want a clue? Okay, I'll just give you a clue. Which of this position is tougher when you do exercise?
So B.
Why?
Sorry, A.
A is tough.
No,
is
sir.
tougher.
Yeah, it will be tough.
A is tougher. Is there? Do we have consensus that A is tougher, or do you want to try now and find out?
B is tougher.
Shivananda is the yoga girl, so she tells B is tougher. Okay. So A or B, which is tougher for most of you?
A.
Shivananda, why you said B is tougher?
Sorry, A is tougher.
I was surprised. How can you tell, being the domain expert in yoga? So now you tell me, why is A tougher? You are right. I agree with you. A is tougher. You see, B, yeah, it is much easier. If this leg was full down flat, it is much more easier. But this lifted is tougher. Why? So Shreyesh is telling we are holding the weight of the leg. So in the other one, you are not holding the weight of the leg. It's your leg, Shreyesh. It is easier to fall down from A. That is right. Why? You are right. All of you are right. I'm asking the question, why? Distance is lesser. Okay. Anything else is striking? Just think of it. Assume you have a big rod or something, okay, which you hold on your hand like this, straight up. Now you know that you can hold if the mass is not that very great. But the same rod, if you hold it like this horizontally from here, if it is lengthier, it is tough, right? Is it not? The rod vertically when you hold, whatever is here, if you hold it horizontally like this, if you catch it on the tip, it is tougher, right? What will happen if the length of the rod is more? It becomes more tougher or easier?
More tougher.
More tougher. Why?
Tougher.
Why?
So the person in the A position has more surface area compared to the person in B position.
Yeah, so that should be easier, right? It is tougher.
No, it should be tougher, sir, because he's holding the entire weight. But in B, it's like he's already folded, so he's only holding like a quarter of the surface area.
Surface area. You have somewhere coming closer to stuff. You tell me first of all why things fall. In the first case, you are telling the leg has more chances of falling. Why?
Due to gravity.
Ah, okay. Now you come to point. Okay. So why do some things fall? Why do some things don't fall?
So all things which you throw up will usually fall, except unless and until they're made out of gas.
Yeah, correct. So, but if I keep my mobile like this straight, probably if I have support, it will stand. But if it is tilted like this, it will fall, right?
Yeah.
You also, as a human being, if Aaron is standing like this, you stand. But if you are in a bridge, if you tilt like this, you may fall, right?
Yes, sir.
So, what makes you fall?
Center of gravity.
Center of gravity. So, what in center of gravity, if you have, you won't fall? Why you don't fall when you stand up? Then also you have center of gravity.
So because your entire mass is distributed equally on your legs.
Okay. Can you improvise? Shivananda, you should tell this. We have discussed this in and out in our science session.
The center of mass.
Center of mass, center of gravity, yes. Center of gravity is in the center. See, the simple thing is some things fall when the center of gravity doesn't have support. You are able to stand because your center of gravity has support. So when you stand like this straight, your center of gravity has support in your leg. When you tilt like this, your center of gravity doesn't have support. Anything falls when its center of gravity is not supported. You have a pen, if you have a base, if you keep a base like this for this pen, it doesn't fall because its center of gravity has support. Slight tilt, also it will support. More tilt, center of gravity will be here, no support, it will fall. Do you all understand this? Are you clear with this?
Yes, sir.
Now you tell me why A is tougher compared to B in this case.
So the mass is acting outside the center of gravity.
Exactly. There is no support. In the case of B, you have support for the center of gravity. See what happens, for this weight which is on the top, which is hanging, assume the center of gravity of this portion is somewhere here, it has support. Here, it will be somewhere here, it doesn't have support. So if you have a rod, if you keep the rod like this, the center of gravity you are supporting. But when you keep the rod horizontally like this, center of gravity is somewhere there. So you have to exert so much of weight. And the lengthier the rod is, you have to put so much of force. Right? Do you all get this? Okay. Now let us go back. Now you tell me what is the difference between these two bridges. Whether given the same condition, this kind of a support, you need more force, or this kind of a support, you need more force.
So the center of gravity is supported by the ropes.
That is right. In both cases, center of gravity is supported, otherwise bridge will fall. Right, Abel? Center of gravity is supported, but which method needs more force to support? This A or B?
A needs more
A needs more. Why?
because its center of gravity is in the middle, so it doesn't have the support in the middle. But in B, it have support.
Yeah, but this is giving support to some method, right? See, both bridge has support, otherwise the bridge will fall. Both bridges do have support. That you have to be very clear. But the nature of support is different.
Sir, in B, the center, it's like the force is evenly distributed because of the pillars, and then in A, more force is required because.
Okay, but I'm telling, assume all conditions are same. Don't think here there are more pillars. That is only picture-wise, which is this thing. So we are trying to understand the concept. So don't think there are more number of pillars here. Assume only 2 pillars are there here. Only the method you see, this method you are pulling from here. This method you are supporting from here. Okay, I will give you one more clue. Now this person is pulling this, right? He wants this to fall here. Now if this person was slightly in front here, he has to apply more force or less force. If he's standing here, so this is like this. Now assume he's standing here, that means he'll pull like this. So he needs more force or less force to pull it here?
More force.
More force.
The closer he is to the tree, he has to apply more force.
So what if this person is standing on another building here, same height, so that this rope is straight and pulled? He needs more force or less force? Suppose he's standing on a pedestal, so that this rope is not, it is straight, same height he's standing and pulling. He needs more force or less force?
So more force, right?
More force.
Okay, are you sure?
So more force will require, and in the picture less force compared to the pedestal.
Okay, so okay, so see, here comes a very important thing.
Sir, less force.
Yeah, there is a very important thing. So you see, assume you have a rod. You can try this at home if you want. You catch a rod like this, and a straight rod or something with some 20 kg, 30 kg mass, which is length there, and you hold it on one side of it. And you see how much force you require for that, for holding it like that, compared to you supporting from down. So there is this tricky stuff that if you take all these examples, whatever we have taken in this case, so you are supporting what? Like all of you have told, you are supporting the mass of this bridge, right? The gravity of this bridge, is it not? That is what you are supporting, right? The gravity force. So you are trying to support it against the gravity. That all of us are clear?
Yes, sir.
Right? So this will fall down. So that means the force is acting down. So we are giving a force upwards, right? That is what this pillar is doing. So this bridge wants to fall down, this bridge wants to fall, but this pillar wants to support it up. Exactly opposite. That is what is the force of gravity. But here you see, you are applying it at an angle. Is it not? Are you not applying it in an angle? It is not straight here. What if this rope you are tying from here? You are tying from top now. What if you are tying from here? Now it is you are tying from top like this. Instead of that, you are tying from here. What will happen?
So it would fall, sir.
It will fall, or you need extremely high force if you are pulling from here. The moment you lower this point of support, the force you have to apply will increase. But if you are holding straight from the top, by some mechanism like this rope or something, straight from the top like this, you need lesser force. You understand? Are you able to get that concept? If we draw it, what happens is this is a very important concept in science and math. Like, here we are trying to support this from here, like this. We want to support because the force of gravity is down. So we are trying to support it from here, right? So you can support this in two ways. Either you can support it like this from here, or from top you can put a rope like you can put a rope like or you can put a rope like this and support. Both these are same. Either supporting from here like this or a rope like this. Both are same. But here what are we doing? Here we are doing a tricky stuff. Here we are supporting from here. So you need more force. And if you are supporting like this, you need further more force. If you are supporting like this, it is like that road you are holding. You need much further more force. Even in that tree case, if you take, oops, where is that? Even in this case, if this person was standing here, and if he is standing here, he has to apply so much of force. And if you are standing straight up here, so much of force for what? To pull this here, you need so much of more force. If he wanted to pull this on this side, which means what? If he would have been applying like this at same height, actually lesser force would do. The more this angle is, you need to apply more force. Actually, in practical day-to-day applications also, if you observe, you can find it out. If you look at it, if you just hold a rope like this, you will find it out. For something to hold like this, if you have, just assume you have a bag of something, you just hold the bag like this, straight. That means you are supporting on top like this. You just measure how much support you require. After this class, just try that. Take a bag. This is a bag. And just hold the bag like this. Then hold it on a rod or something. Like this in this angle or in a rod and hold it. Same weight, same mass, same bag. You will need to apply more force. Are you able to visualize? Are you able to visualize?
Yes, sir.
Yeah. So what does it mean? So that means a very simple, straightforward principle that if you apply a force like this, actually the force which you wanted, the force which you need is like this. This is the support you want. For that, if you apply a force like this, the 100% of it will not come here. Some percentage will go. Will go where? The energy or force doesn't go away, but then if you apply, the 100% won't be coming here. And if this angle is increasing, if you are applying from here, you get much lesser force in this direction. And if you apply from here, you get much lesser force again. And if you apply from here, like Palash told, it may break down, you won't get anything. You are applying perpendicular. Yeah.
In that case, there's almost no force being applied.
Or no force will get applied if you are applying perpendicular. But if you are applying it here like this, like to lift it like this, yes, the 100% gets applied because it is the same direction. So the direction in which you apply the force is important. So if you apply the force in this direction, what happens is that force, all this will have, it will get split into different components. Okay. So in other words, listen this carefully. In other words, if I want the support like, if I want the support like this, but I don't want a pillar here. The best thing is to give a pillar, but then my ship won't go. I want this to be flat. So we go with this cable arrangement. So with this cable arrangement, if we give a support like this, that means all the force which you apply will not get applied in this direction. Only a percentage of it, a part of it will get in this direction. Another part will go to this direction or any other direction. If you see closer to this, you will get more force. Closer to this direction. In case you want to pull it in this direction, this will give the maximum. So from the direction in which you are applying the force, in the same direction is where the maximum force will apply. The more you go away from this, the effect of this force will get reduced. So if you are, that is why there is a height for this. Otherwise, you can type from here. If you type from here, the force which you get is further away from here. So the support you will get is further less. Actually, then you will ask, why can't this height be equal? There's a limit, right? Then the stability of this pillar will get affected. If this is 1 kilometer height, actually this will get closer. So you will get more. But then this 1 kilometer stuff business is very difficult. So there are some practical calculations. Do you all understand this? Okay. So it's all same here. It's all the concept is like you, if you need support for the center of gravity. And here also you see, you want to actually hear where is the force coming in this case. In this case, actually speaking, what this gentleman is trying to do is to apply a force like this. No, means straight I'm not able to draw, but straight, you want to pull it here, you want to apply it here. So if you are standing at this height and pulling, see, lesser force should have been sufficient. But you have practical problem because you can only stand here. So he is pulling from here. He's pulling from here. So one component of him will come here. But if he was standing much more closer, if you are standing much more away, he would have a bit more component. If you are standing here, the component which goes to here will be much less. Yeah. In the previous case, it was center of gravity support. That is a vertical force. Here it is the horizontal direction. Only the direction is different. Get this? Okay. So now let us get to the maths of it. Let us get to the maths of it. In maths, how do we deal with this force business? So what did we say? So we say if you apply a force in this direction, the 100% of it doesn't get applied. 100% will get applied in this direction only. If it is a bridge, like I think it is a force here, the force which will come here, like the rope or you are pulling the tree case, this will be only a percentage of this force. You won't get the 100%. Okay, right? And how much force you get here is depending on what? What will decide how much percentage force you will get in this direction? What parameter will decide?
So is it f cos theta and f sine?
Yeah, but what parameter decides how much force you will get here? What parameter is deciding?
So is it the angle?
It is the angle. Yeah, it is this angle slope. It is this angle, right? So if this angle is more, you get much lesser force. That's what we found out here. Is it not? If this angle is more, you want to get the force here. If this angle is more, that means which direction actually you want to get the force. If that if that is making a wider angle, more angle, you get lesser force. Even here, that's what we found out. You need the support here. You need the support like this here. So the angle we want the support like this, like this. So this is, we are applying it here. So this angle makes a difference. If this angle is more, you will get lesser only. That means where you are applying force and where you need it, there is a big difference. And if this angle is less, you get more force. If this angle is further less, you get more force. Right? That's what we are establishing. So same way, if you look at it, if this is this force, what angle will come in this direction is only a fraction. And in the case of the bridge, we were supporting like this. This is in the case of tree, we were pulling it horizontally. This is in the case of bridge, we want to support the center of gravity. So if our cable is in this direction, this angle will decide how much support you will get. The more this is on this side, you will get lesser support. The more this is on this side, you are closer to the need of support or force, you will get more force. Right? Do you get this?
Yes, sir.
So now if this is the force, what you get in this direction or this direction. See, this is case similar to the tree pulling horizontally, right? This is similar to the case of the bridge, and this is the cable bridge. Okay, only that angle this thing is changing. In either case, you won't get it full, and it is depending on the angle it makes, right? So this angle will decide. This angle will decide how much you will get. Assuming this angle is some figure, some value, this one. Okay. So actually speaking, what happens is, if you assume this is the force, if you put some light, assume a light is coming from the top, okay, like shadow of this. So this is the shadow. This is the shadow of this angle. So this much you can visualize it as, this is what actually you will get in this direction. Now what will happen to the shadow? If this angle is more, the shadow will increase or decrease? If this angle is more, that means if this becomes more and more straightened, this shadow will increase or decrease?
So it will decrease, sir.
It will decrease, right? All of you, do you get that?
Yes, sir.
Yeah, if this gets straightened, what will happen? This will become like this.
So the shadow would be really close if it's
Yeah, then
straight.
then the shadow gets reduced. It's only here, right? And then if this is like this, that means axis further increase. Shadow is only this much. That is the same. So the shadow you can consider as an equivalent, or to understand in simpler terms, you can consider like when the angle increases, the shadow will reduce. This is very similar to the force which we are talking about. Yeah. So whatever force we are talking about, how much force you will get here is depending on this angle. If this angle increases, the force which is getting applied will be reduced. What if this angle reduces? Will increase or decrease? It will increase, right? What Abhay is written, like if this angle x reduces, this will increase, because then obviously what will happen if this x reduces, this will become like this. So the effect of this shadow part, this will increase. And if x further reduces, because the value of f doesn't change, right? The force which you are pulling, like in the case of our cable support, if the cable comes closer to this direction, then this portion will increase, right? The shadow and also the force which you get. So the shadow you can consider in your mind for a visualization. This is like a shadow, how much force you will get. You understand?
Yes, sir.
Okay, and then the opposite will happen for the support. So if this angle increases, what will happen to this shadow? This is also shadow, but what is the difference? This is the shadow when the light is hit from here. So this shadow, when this angle increases, this shadow will keep on increasing. If this angle increases, this shadow will keep on increasing, right? That is opposite to this force which is coming here. Is it not? When
Yes, sir.
when
Yes.
this angle increases, this shadow is increased. When this angle further increases, this shadow further will again increase. So that means the loss for the force in this direction will be the gain for force in this direction. Which means, what does it mean? If you apply a force in an angle, that force gets split into directions, right? So in the same direction where you apply the force, you will get 100% force. If you're pulling something like this, in that direction, you will get 100% force. But then you get much lesser in the directions like this horizontal here, or you will get much lesser. And this angle will decide how much you will get for the support like this vertically, and in the horizontally what you will get. If the horizontal component is more, vertical component will reduce. So when this angle increases, the vertical component will increase, but the horizontal component will reduce. If this angle reduces, the horizontal component of the force will increase, because this is coming closer to this vertical component will reduce. You all understand this fundamental concept?
Yes, sir.
Anyone doesn't understand, please feel free to ask. Okay, so this is the base. Okay, so now let me ask you, now you tell me how much component I will get. We told only a percentage of F we will get. We won't get the full F here. F is the maximum force. The maximum force through this pillar or the tree which we are pulling, that is the maximum force. And that maximum force you get only in this direction. So in this vertical direction, you can assume, for you to easily visualize, you can assume it is like this shadow falling this much only, just to visualize. Okay, even the example you understood. If you apply through a cable, a pillar support for a bridge, only a portion of it will get. That means F, only a percentage of F you will get here. What is that percentage? What is the percentage of this F or force which you will come? See, assume this is 100. Okay, this will be less than 100. And that is also depending on this angle. If this angle is less, this means if this angle is less, for this 100 you will get much lesser. If this angle is further less, you will get much lesser. What happens if this angle is 0? If this angle is 0, how much you will get here?
Sir, no, nothing, sir.
0 you will get. If this angle is 90 degree, what you will get?
So you'll get 100.
You will get 100%, full F you will get. So when this X is 0, this value of this vertical support you will get in the center of gravity. You want the pillar here. If you are pulling 90 degree opposite, the bridge will fall down. Right? So, but if this angle is high from the top, if you are holding like this, instead of giving support from bottom, if from the top, if you are holding in the same line, it is equivalent, same 100%. You understood? Instead of, it is like instead of keeping a bag in your both hands like this, you are holding bag like this. Both are same. You are supporting center of gravity. One like this, one like this. So now you tell me how much percentage you will get.
So could you repeat?
We are telling you won't get 100% of F here, except when this F is, when this angle is 90 degree. So in all other cases, you will get only a portion of f here. That means a percentage of f only you will get, right? What is that portion? Abel, you are telling by looking at this drawing. Okay, this x can vary. Abel, don't look at this drawing by thinking I have drawn that x is at approximately 45 degrees, something like that. Don't look at that. That can vary. So that means how much percentage you will get is a component of x. You have to understand, right? When x reduces, you will get less percentage. When x increases, you will get more percentage. What is it called? Just try. Wow. Abel, I will buy you a chocolate. So that is what we call as sign. The component, how much percentage you will get in vertical is what we call as sign. You know where that word comes from? That word comes like this. Aryabhatta used to use this word in Sanskrit called jia. Jia is chord, jia in Sanskrit. So in his Aryabhatiyam, most of the places he used to call it a jiva, right? Jiva. So half chord used to be called as ardhajiya. So short form it, small chords, he started writing jiya. When Arab travelers came to India, when they translated these books into Arabic, in Arabic they don't use much ya, most of it called ba. So they started calling it jiba. Then by pronunciations, slowly this jiba became jaib. Those who understand Arabic, Hindi and all will know jaib is pocket. So when the Europeans, they started translating this into Latin, they translated this pocket, or they thought it is like bosom or the curve. They used a word called sinus. And that is from where in English sign comes. You see how interesting the way the knowledge travels around the world. Yeah? This word, have you heard any other place? Sinus? Sinus?
Sinus infection.
Ah, exactly. It's all coming from the same stuff. Sinus, cavity. Sinusitis, have you heard?
No, sir.
Sinusitis, sinusitis, people will have sinusitis, something like migraine.
Oh, yeah.
Yeah. Right? So this is called sign. The component of f, how much of that component will be available in this vertical is sine. So sine of f into sine of this angle is what you will get here, right? F into sine of this angle. Now by seeing this itself, you will know the characteristic of sine. What will be the value of sine x when x is 0?
0.
0. Because when x is 0, you don't get anything here. It is f into 0. Is it not? See, from this diagram, from this concept, you understand the concept, okay? Don't by heart sine, cos. The whole purpose of this class, this course is to get you away from the by hearting business. Okay? So understand the concept. If you don't understand the concept, ask. So now, what will be from this figure itself, you will know what will be the value of sine 90. What happens when this is 90 to this?
So the value becomes 1.
the value will become 1 because when this is 90, F and this are same. This guy will come stand straight here. Is it not? Everyone? Do you all get it? I want to ask everyone, if you, those who understand this message, yes. If you don't understand message, no. I don't have any problem if you tell no. I'm ready to explain it umpteen times. This thing has taunted me throughout the life, not just me, many people, almost all of us students, when we were studying without understanding what does all this thing mean. So if you don't understand, don't feel bad. These are things which has haunted students, continue to haunt. So no problems. It's important to understand. Yeah, Navneet is asking, can you please repeat it? Very good. I'm happy. Navneet, did you understand that cantilever, that cable, that support, that example?
Yes, sir.
Did you understand that concept that if instead of giving a support to a bridge like this, if you give a cable support in an angle, the 100% of it will not come as here. Did you understand that concept?
Yes, sir.
Okay. So now we are bringing it pictorially here. And why I'm asking that, otherwise I have to explain it again. Okay. That tree, did you understand the tree we were trying to pull the tree? Did you understand that example?
Sir.
Yeah. So all these are same examples. Only difference in tree was about horizontal movement. We are trying to move the tree horizontally. In the case of bridge, we are trying to give a vertical support. That is only difference. But both were giving a force in an angle. In a tree, we were giving a force with a rock. In the case of a bridge, we were giving a support from a cable. So what are we telling? If you give a force like this at an angle, the 100% of the force will be available only in this direction. Okay. So if you give a cable support like this, assume this is the cable. Navneet and others, don't feel bad if you don't understand something. Feel free to ask. This is not a sin or crime. Not asking if you don't know something is the crime. So assume this is the bridge. Assume you want to, 1 second. Assume you want to give support like this. Yeah, assume this is the pillar you want to give. Assume this is a cable like this. Assume this is the cable like this. Okay. So, and that when you give a cable pull like this, if this is the bridge, if you cable like this, you won't get the 100% of F in this direction. This and this are same. Whether you support like this or, sorry, ulta, whether you support something like this or hold like this are same. Whether you keep a bag like this or with the holes like this, both are same. You are working against gravity. Only your position of holding is different. One you support like this, another you hold like this. Okay. So in the cable bridge, you hold like this. In the pillar, you support like this. So when you have a pillar, a cable like this, 100% of the F won't be coming in this direction. That's what we are telling. Okay. Navneet? Yeah. Now, even in the case of tree, we are pulling. If assume this is the tree, you are pulling the tree like this. You want the tree to move like this. So you want the force in this direction. But if the person is pulling the tree with a cable like this, 100% force will not come in this direction. Only a percentage of it will come. We are trying to calculate how much is that percentage. Okay. So now we are telling that is depending upon, now we are generalizing, clubbing all the cases and generalizing it. So now we are telling only a percentage of it will come in the vertical direction. Only a percentage of it will come in the horizontal direction. And that is depending on this angle. Right? Okay?
Okay, sir.
Yeah. So the percentage which will come on this vertical direction, we told this is sin x. Now you tell me what is the percentage that will come on this direction? What percentage of F will come here?
So will it be F cos?
Exactly. So the percentage is called this. percentage is in this direction is, what is meant by complement?
In relation with,
Complementary angle, complementary.
Is it like 1 minus sign?
Not really. What is complementary angle?
Is it like the force you're giving to the other direction?
Yes, but what is complementary angle?
Two angles that form 90 degrees.
Yeah, complementary angle, two angles, those who haven't studied, you understand, if this is x, this is its complementary angle. Complementary angle means you are complementing, both together will become 90. What if we tell two friends are complementary? Both of them together will succeed. That is when we call one person, what one person doesn't have, the other person will come. That is called a good team, right? Complementing team. Understand? The English word itself means that. So this person gives this angle, this person will give this angle. Together it is 90. It's called complementary. So this cosine is called complement of sine. You know why? It's called complement of sine. We will find out. So this value, like Palash told, so normally we write the short form as cos for cosine. Okay, so what is the simple thing we are establishing here? If you have a force like this, I will take 5 more minutes only, with that will close. Okay, if we have a force like this, only one portion of it will get applied here. See, this is not like it will get applied only in vertical. It will get up. If you want to support here also, there can be a force. If you want to support here also, there will be a force. But we normal applications, we will give support either from here in for a center of gravity, or like the beams in the building from this. So that is why we are only considering horizontal and vertical. It doesn't mean there won't be force here. This can support something like this also. This can support something like this also. That all things are there. Okay. So now we are telling of this force in the vertical direction, only sin x percentage of F only will be appearing. And in this horizontal direction, only cos x percentage of F will be appearing. So now you tell me what will be the nature of cos x, what will be the value of cos 0? What will be the value of cos 0 by looking at this? What happens? This is 0.
so the value will be 1.
When this is 0, this force and this has no difference. It's in the same direction. So 100%. Is it not? When this x is 0, this force and where you want the force are in same direction. So you don't lose anything. 100%, which means cos x is 1. The maximum value is 1. This person, maximum value, this can't be more than f. Right? And what if x is 90 degree? What will happen to cos x?
Cos x will be 0.
Cos x will be 0. Why? Because this is opposite. I want the force like this and this guy is pulling in 90 degree opposite. I don't get anything. In the case of sine, it is complementary. It is opposite. Why it is opposite? Because the loss of this is the gain for this direction. So when this is 0, the 100% is aligned to this horizontal axis. So vertical axis will not get anything. Because you are taking this angle, not this angle.